Every night, as the stars come up, mankind looks at the sky and wonders, are we really alone in this infinite universe? Everybody's fascinated with the subject because it answers basic questions such as where do we come from, what is the meaning of our existence, why are we alone, why us? If other life forms exist, where are they? On the dark side of the moon? Mars? Further away? And what do they look like? How did I imagine aliens to be? I used to fantasize them like the ones on TV, green or covered in tentacles, things of that nature. But with time, now that I'm an adult, I realize this is just for Hollywood movies, not real life. To me, alien life is probably more something like bacteria that we may find on Mars' surface. Since we've been technically able to, Earthlings have examined each star. We've listened to them. We've sent space probes, messages, and even fellow humans to other stars, with no results.
It's always been a source of fascination for mankind. 5,000 years ago, men looked up and watched the stars, and since then the question remained unchanged. Are we alone? Not much progress has been made.
However, over the last decades, the exploration of Mars and the discovery of thousands of new planets outside our solar system have given new hopes to those who seek an answer.
People have been wondering if we're alone since the dawn of time. But in the last 25 years, although we've not found an answer, we now know what we should do to get an answer.
My name's Thomas Pesquet. I'm an astronaut. I'm in training for a mission, 6 months in the International Space Station. I think future space conquest is very important for everyone. The further we look into space and the more we look at our past, it's clear that a planet like Mars is where our future lies. We're advancing in an environment which is difficult, but we're advancing quickly. It's an incredible journey. Let's pursue this adventure together. You won't be disappointed.
This is Houston. You are go for LOI, over. Roger, go for LOI. And we've had loss of signal as Apollo 11 goes behind the moon.
When we left the Earth's atmosphere, the first place we explored to find signs of extraterrestrial life was the surface of the moon. The 20th of July, 1969, for the first time in human history, an Earthling lands on another celestial body.
There you go. It's one small step for man, one giant leap for mankind.
On that day, the whole world is watching, staring at the silver screen with one question in mind.
Roger. And we're getting a picture on the TV.
Is there life on the moon?
Absolutely no trouble to walk around. It has a stark beauty all its own. It's like much of the high desert of the United States. It's different, but it's very pretty out here.
At first glance, the crew of the Apollo 11 mission can't see any signs of life. So what about life within the moon's soil? Are there any bacteria? Are there traces of water? To answer these questions, Buzz Aldrin and Neil Armstrong collect some 47.5 pounds of lunar material in just a few hours before heading back to Earth.
Roger, we got you coming home.
On July 24th at 16:35 UTC, after the capsule's splashdown into the Pacific Ocean, the crew is immediately quarantined for 21 days.
The goal was to make sure they didn't bring any pathogen agents back with them, biological or otherwise, that could potentially contaminate Earth, like a virus, for instance.
After a series of tests, nothing was found. No biological residue either on the men or in the samples. The moon is declared barren. Our natural satellite shows no sign of extraterrestrial life. The following year, NASA tries sending messages to potential aliens. In 1970, a plate is attached to the Pioneer 10 space probe, the first terrestrial device to explore the galaxy beyond our solar system. Its mission is still ongoing.
Et les Américains ont pensé à tout. À bord de Pioneer 10, ils ont placé une plaque portant un message qu'ils estiment universel. Voici l'atome d'hydrogène, parce qu'il est le corps le plus simple. Ceci, c'est une carte de l'espace indiquant les directions de radiosources, directions écrites en langage binaire. Ceci, c'est notre espèce, avec derrière la silhouette de l'engin pour donner une échelle. Fin du fin, cette main ouverte pour que les extraterrestres sachent que nous avons 5 doigts. Enfin, l'endroit où nous habitons, le système solaire, avec la trajectoire suivie par l'engin. Voilà la carte de visite de Pioneer 10.
There will be other messages. 7 years later, a gold-plated disc is placed inside the Voyager space probe, featuring natural sounds of the Earth. And a peace message read in 55 languages.
Hello from the children of planet Earth.
The most important thing we need to show other evolved life forms is our goodwill. Maybe it's not always obvious, but on the whole, mankind is full of goodwill. We need to say, we come in peace. We're not a belligerent species. Much too often we're at war on Earth, but globally, I don't think it's human nature.
I think a lot of people believe that we're sending messages into space waiting for the aliens to reply. I mean, you can do that, and it has been done a little bit, but of course it might take a long time before you get an answer. Could be thousands, even millions of years, so, you know, that's maybe not the most interesting experiment. But it has been done, mostly as a kind of a demonstration project, just for the fun of it. There was a message sent from the Arecibo telescope in Puerto Rico in 74, and you know, it was a very short message. It was like 1,700 bits. You know, there's more information in any paragraph in a book than in that message, but you know, it was kind of fun. The NASA has sent a Beatles song to the North Star.
Nothing's gonna change my world. Change my world.
Nobody's responded yet, but the North Star is 400 light years away, so you got to wait on 800 years before you find out whether the aliens like the Beatles.
Will we ever get a message? A sign from above? In the absence of response, mankind's imagination went wild. Aliens are depicted as angels traveling in flying saucers or little green men with a menacing stare.
If we ever met aliens, as they do in the movies, they would necessarily have a strange face. But if you think about life on Earth, really, a giraffe or a shrimp isn't any less strange. Only habit tells us it's not. There's no reason an alien should look any more like us than a giraffe or a shrimp does.
What if life beyond Earth's limits wasn't what we imagined?
When we talk about life, we have very modest expectations. We only talk about the most simple of all forms of life, the bacteria. It's impossible for us to imagine a more evolved type of life form. We just don't know.
So the search is on for bacteria as well as little green men. A wide range of contestants, really. But how can we identify their existence when we know nothing about them? To look for life, scientists have based their research on the study of the only life form they know exists in the universe, ours.
The search for alien life forms obviously starts with the study of how life appeared on Earth and how it evolved on Earth.
That's when we start considering how other planets, let's say Mars for instance, may have had properties similar to the ones that existed on Earth when life appeared. In this hypothesis, life could have existed on Mars. By asking ourselves the question of the origins of life on Earth, we open doors behind which we have a chance of discovering something.
Humans are one of the latest arrivals in the history of our planet. Indeed, the earliest signs of Homo sapiens life are just 200,000 years old. But life itself already existed in the dark ages of Earth, 4 mega years ago, in the form of microorganisms.
The scientific theory for the origins of life on Earth relies on the presence of liquid. And most people think that the best liquid for life to be created is water. Water exists all over the universe. It exists everywhere in the solar system, either as a solid, ice, or as a gas, vapor. On Earth we have ice and vapor, but we also have water in its liquid state. That's the first element. The second element of life would be carbon-based molecules, what we call organic matter. We think that the combination of small carbon-based molecules and liquid water has helped the chemistry of the Earth to cross a line, reach a new level of complexity that later would trigger the mechanism we know as life.
Carbon molecules and liquid water seem to be the key to the origins of life on Earth as well as on other planets. But with the first telescopes, men started looking in the direction of Mars.
The focal point, if you talk about life in our universe, has always been Mars, very early on. Simply because when you start looking at Mars, as it was done as early as the 19th century, the first thing you see is the polar cap, the south polar cap, because that's the one you see when Mars is close to Earth. The reasoning is, polar cap means ice, means water, and where there is water, there's life. That's how people thought back then. This reasoning may seem simplistic, but that's how the myth of life on Mars started.
Since men left Earth and landed on the Moon, the primary objective of all space exploration programs has always been Mars. In 1965, Earth discovers the first images of its cousin planet and closest neighbor. Great joy, but also great disappointment.
You've heard about NASA's Viking missions that landed on Mars. There have been 2 of them. At the same time, everyone believed life existed on Mars. The instruments were designed to detect life, not traces of life if it had existed. The tests could spot life as it existed on Earth, but the machines weren't designed for a Martian environment.
Today we know there are no living life forms on Mars' surface, but that doesn't mean, firstly, that there's never been life on Mars, and that's what we're looking for now, and secondly, that there isn't life now, but maybe hidden underground, where research is much more complicated.
Since its successful landing on August 6, 2012, American rover Curiosity is still exploring Mars. Its mission? Determine if Mars' environment ever was suitable for life to exist.
It's very difficult to get hard facts about the most primitive traces of life on Earth. So it would be foolish to imagine going to Mars, throwing a pickaxe at a rock and finding definite answers to all of our questions. Maybe if we find the bone of a dinosaur or an actual living organism on the surface of Mars, maybe then we can make conclusions. But barring this possibility, it would be a long process that will require the return of samples to Earth.
We'll have to dig into Mars' soil, retrieve samples and analyze them if we want to maybe discover organic components and microorganisms. If we want to know if there ever was life on Mars, we'll need such a mission.
Over the next 20 years, we'll be able to bring samples back from Mars to Earth. If the samples have been chosen carefully and if life indeed ever existed on Mars, it will be proof. If the answer is no, we can close the subject of Mars and carry on with the research elsewhere, but it will take another 20 to 30 years.
If not on Mars, where could life be hiding? Over 20 space probes have been sent to Jupiter, Saturn, Uranus, Neptune, and even Pluto. For the moment, none of them have discovered any signs of extraterrestrial civilization. But each new image sent by our probes raises new hopes of discovering other life forms.
There certainly are many other interesting places to look. Some have only been discovered quite recently. For instance, icy moons that gravitate around giant planets of our system. Jupiter, Saturn, maybe Uranus, Pluto. Europa is probably one of the most interesting places.
These icy moons have a hidden secret. Their thick, icy surfaces conceal actual oceans.
The ocean is in constant contact with minerals. What happens when water is in contact with rocks? Water becomes salty. So this water is rich with minerals. And these minerals are nutriments for potential bacteria.
If life appeared there, it appeared without any solar energy input, because the surface of the ice completely blocks it out. So if we find life in this kind of environment, if there is any, we'll learn a lot about how life is created. Life on Earth is our only example for now, but I hope it's one amongst others.
Life under a sheet of ice. We still lack the technology to verify this hypothesis on Europa or Charon. But on Earth, one example is giving credit to this theory: the abyss. At the bottom of the oceans, where there is no sunlight at all, life abounds. Near hydrothermal water vents, creatures have adapted to these extreme conditions.
On Earth, actually, life has managed to adapt to every kind of environment possible.
These recent findings open up new possibilities. Life in our solar system and beyond could actually be more diverse and more present than we think.
It's frustrating because we'd love to know right now if aliens exist. In any case, we don't know if we are alone in the universe, which would be more complicated to explain than just saying, there's life somewhere else in the universe. Another way of seeing things would be to say, wherever there's water and organic matter, there must be life. And we will find life on Mars, in the oceans of Europa, everywhere. But if we only find life once every 10 times, we find water and organic water in the solar system, well, then we just have to be glad we're here on Earth. It also means that once every 10 times, we might find life on exoplanets.
In 1995, we got proof that our solar system wasn't unique. The universe is full of stars, with dozens of planets orbiting around them. The ones we call exoplanets maybe host life. I'm not hunting for exoplanets day in, day out, but I'm interested in them, especially when they have characteristics close to our Earth. This happens quite regularly on planets in areas close to their stars, where the temperature and pressure conditions would make life as we know it possible. Recently, we found an exoplanet with a man-made looking structure orbiting around it, like a black star. Everybody started fantasizing about it, but it was nothing. Regularly, something like this comes up, and you can see people getting excited. If you read, "We've found Earth's twin sister," NASA or ESA won't be the only ones to care. Everyone's going to want to read about it. The hunt for exoplanets started near Aix-en-Provence, in the heart of the Parc du Luberon, at the observatory of Haute-Provence. In October 1995, a Swiss scientist, Michel Mayor, and his student observe a giant planet orbiting around star 51 Pegasi.
Cette planète est incroyablement intéressante parce que c'est la première preuve d'un objet aussi léger autour d'un autre soleil que le nôtre. Par ailleurs, c'est remarquable parce que cet objet-là n'est pas du tout en accord avec ce qu'on attendait pour de tels objets. Si notre vieux Jupiter, notre grosse planète du système solaire, tourne autour du Soleil en une dizaine d'années, cet objet-là, avec la même masse, lui, ne tourne qu'en 4 jours autour de son étoile. Une étoile par ailleurs très similaire au Soleil.
C'était une découverte.
This was a breakthrough.
À la révolution,
Some compare it to the Galilean or Copernican revolution.
À l'époque de Copernic,
in Copernic's time, people believed the universe revolved around the Earth. Then we discovered Earth actually revolved around the Sun. With the first exoplanet, we discovered the Sun was one star among many other stars, a rather random, smallish star, and that the fact the planets orbited around it wasn't anything exceptional.
With its top-of-the-range spectrograph, the observatory of Haute-Provence's telescope is still one of the best in the world. And that's lucky for astrophysicist and planet hunter Guillaume Hébrard.
Several experiments have been carried out to study the stars with the light that was captured by this telescope.
To find a planet, you have to study the star first and spot an irregularity in its movement.
To find exoplanets, we use an indirect method. The direct method would be just to look at the star with a telescope, take a picture and observe a little dot on the side. We would follow its course around the star and know we have a planet. But no one knew how to do that in 1995, so an indirect method has been used. The method is called the radial velocity method. You don't see the planet, but you can see the star quite clearly, and you're able to measure its movement. If a planet rotates around a star, it will have a small effect on the star's position. It's like a hammer throw. The hammer makes the thrower move a little. The bigger the hammer, the more the thrower moves. So the bigger the planet, the more the star is deviated from its position. That's why the first planet we discovered here in 1995 was a very big planet, a giant planet. The planet was as big as Jupiter. So if you want to detect smaller planets using this method, you need very precise instruments.
Thanks to this spectrograph, Guillaume Hébrard contributed to the discovery of a dozen planets.
I found one, KOU 889b, not the sexiest or catchiest of names, but when you discover a planet, it's an emotional moment, especially because there's a moment when you're still not sure, just before you become 100% sure, before you know you've actually found a new planet. You made a true discovery. It happens every now and then. It's rather rewarding.
Each session begins at sunset, after the dome opens. The machine operator places the telescope in the direction of a star to capture its light for 10 to 30 minutes.
The image is analyzed by the detector. The image comes up on the screen here. That's the orange image we see. It represents the star's spectrum, all its different orders. We see how much light there is according to the wavelength or color of the star. We measure these absorption rays to calculate the exact radial velocity of the star using Doppler effect. The Doppler effect is a very common method used by the police to determine a car's speed. We use the same technique for stars. That's how we measure a star's speed and determines whether this speed varies with time. And that's how we know if a star's movement is modified by an orbiting planet.
Guillaume Hébrard will still have to observe those stars several times and study their movement over the course of several months in order to statute on the existence of a neighboring planet and maybe one day find a livable planet.
We always had a hunch that there were lots of planets in the galaxy, but for a few years now we've known there's a huge number of them, especially small planets. They're very common in our galaxy, so imagining planets similar to our Earth orbiting around stars that are similar to our Sun that have evolved in a similar fashion is quite realistic.
Since 1995, it's been hunting season for new planets. The number of elaborate telescopes has increased on the ground, in France, Chile, or Hawaii, but also in space, with Kourou, Hubble, and Kepler. Today, the existence of over 2,200 planets has been confirmed, and several thousand more are expecting confirmation, and the search has only just begun. Very soon, new telescopes will be stationed in space, more powerful even than Hubble, like the European Plato or the James Webb Space Telescope and its 6.5-meter diameter mirror, that give us even more accurate pictures of our galaxy. In the next decades, we might discover several thousand new planets. But the real breakthrough isn't in their number.
Actually, when we discovered new planets, although it was quite a discovery, no one was really surprised. What was a surprise, however, is that we discovered types of planets which didn't exist in our solar system.
We speak about biodiversity on Earth, but there's also planetodiversity in the universe.
In this menagerie of planets, life may be hiding on Earth's twin sister, within other living beings.
Rapidly, we thought, if there's that many exoplanets, there's probably many rocky or telluric exoplanets. So probably quite a few of them are in the livable zone, that is to say, at the right distance from their star to be neither too hot nor too cold, and have liquid water. Life on Earth appeared in water, so we don't know how it could appear without it.
If our theory about the beginnings of life is correct, life could spring anywhere in this livable area. So once this area is marked out, how do we detect life from the other side of the galaxy?
Today, the only method we're considering, which isn't science fiction, is to detect signs of life in the atmosphere. Life indeed modifies the composition of the atmosphere. Our atmosphere wouldn't be as rich in oxygen without life. That's why trees are so important.
There's another clue. When you look at the Earth from afar, so far out it's just a dot. It has the distinctive colors of plant life. And by chance, this color is very different from the colors of any known rock. So, if on a given planet we find colors that differ from the listed colors of rocks, it would be a clue that something else might be going on there. Maybe plant life.
So by analyzing the composition of these planets' atmospheres, we should be able to tell whether life is or ever has been present.
Exploration will now matter as much as discovery. Once we have numbered the existing planets, We want to know what they're made of, their temperature, the chemical composition of their atmosphere, if they have one, what's the cycle of days and nights on the planet, and what's their relation to their star. If the atmosphere of a planet is modified by the presence of life on this planet, one day we'll have the means to detect it. On the other hand, one can imagine a number of habitats where life can be relatively hidden with no impact on the atmosphere. In that case, we will have to go over there to explore. Interplanetary travel, however, is still science fiction, and will stay so for at least decades, probably even centuries.
Interplanetary travel has only existed for the last 50 years, and we're still limited to small distances. Our space missions take us some 400 kilometers from Earth to the International Space Station. On November 15th, 2016, when I'll be leaving Earth's ground, my Soyuz space rocket will take me to the ISS in just 6 hours. For Mars, it will take future astronauts as long as 6 to 9 months to reach the Red Planet. These missions will be very long, but still acceptable for men. Could we go even further out? Today, the state of our technology means it would take an 80,000-year trip to reach our closest galaxy, Proxima Centauri. Space exploration is a long road ahead. Americans call it deep space. It's an analogy with deep diving at the bottom of the Mariana Trench. This is what we're going to be doing. We're traveling within the limits of our solar system for now. Later, we might be traveling towards our closest star and beyond. But it's one step at a time, one short hop after another. We may never be able to go there, but we might be able to make contact. Hear a message from a distant galaxy, if by chance we're dealing with an intelligent life form.
There are many ways to define an intelligent life form. It could be a life form that uses technology. So we would be able to observe the technological clues of life, like if you found houses on another planet. Another way to define intelligence is when you're able to make a meaningful contact.
If there is a technologically evolved form of life, couldn't we see proof of it? Several ideas have been developed around this question. For instance, the SETI. The SETI is the search for extraterrestrial intelligence. It consists in listening for a signal whose signature is undoubtedly artificial, not natural.
An international program which began in the 1960s based on a young scientist's unusual idea.
In 1960, Frank Drake was a young astronomer who had a job at the National Radio Astronomy Observatory, and they were trying to think of experiments to use their new antenna for. And he came up with this idea, hey, you know, one thing we could do, I mean, aside from the usual astronomy research, we could try and see if we could pick up a signal that somebody else, not humans, but aliens, if you will, might be sending our way. And he spent a couple of weeks, every day, pointing the antenna at 2 nearby star systems, hoping that they had planets that had beings that had radio transmitters. I mean, he didn't hear anything, but that was the beginning of modern SETI.
This trial period of 2 weeks became a project developed by NASA over 30 years until they stopped it for lack of results. Since, this research has relied on private funding. In 2015, a Russian businessman, Yuri Milner, put the program back on track with a $100 million program named Breakthrough Listen, supervised by celebrity scientist Stephen Hawking.
It's time to commit to finding the answer to search for life beyond Earth. We are live We are intelligent. We must know.
With this initiative, astronomers and astrophysicists received funding allowing them to use more regularly Earth's largest ears, radio telescopes. Arecibo on Puerto Rico Island, Parkes in Australia, Allen Array in California, and Green Bank, just 300 kilometers outside Washington.
Touchdown and just over.
There are 6 telescopes in these mountains in the middle of the radio-quiet zone, including the largest full steerable radio telescope in the world with its 100-meter diameter curved antenna. Dr. Karen O'Neill is the site director in Green Bank.
So the site here has been around for about 60 years, and in that 60 years it's had a number of times where we've gone out to look for what we call intelligent life. And so that's actually looking for a signal from outer space that's clearly artificial. It's not something that you can find a natural source for. And so the hardest thing you can do when you say we're going to go look for intelligent life out in the universe is to try to define what you're really searching for. So what you try to do is you go out and you'll pick up all sorts of signals. Anywhere you point the telescope, you're going to pick up tons of signals. So first you have to say, well, I know what nature does produce. There are things we already know about that are naturally produced, and so we can eliminate those. Then you can go and say, well, what is man-made? So what are human beings creating? And eliminate those. And then you've got a bunch of signals left. And you have to take those signals that are left, and you have to then say, well, I didn't know that humans created it, but could they have created this? If it is definitely coming from outer space, and we don't know of what's of any natural way of producing that, then you've got a potential signal.
All around the world, researchers in all types of fields point the radio telescope to the star or the planetary system they need to listen to.
This is the control room for all of the telescopes here on site. We have a telescope operator that's here 24 hours a day, 7 days a week, that actually monitors all of the various telescopes on site, and most importantly, focuses on the GBT. Occasionally the operator will run a project, but more often they're just monitoring what's going on. So at the moment, for example, we're in the middle of changing projects. So we have observers that are around the world, and they simply log in over the internet and use our computers to run the telescopes, and the operators watch what's going on. So right now we're switching from one set of science, one type of science, to a different type of science.
Since the discovery of exoplanets, scientists primarily focus on listening to the planets we've actually discovered. However, for that type of message to cross the immensity of the universe and be received by our radio telescopes on Earth, it might take light years.
About 4 years ago, the GBT was used to look at what are called the Kepler planets. These are planets discovered by the Kepler spacecraft, and in particular used to look at the most Earth-like planets that Kepler had found to try to listen for signals. And now the GBT is part of a brand new project called Breakthrough Listen, which is very exciting for us. And this is a project to really say, if we're going to look for intelligent signals with a radio telescope, we need to do this very systematically. We need to go and look across a wide variety of wavelengths, and we need to repeat our search over and over and over again on the same objects to really try to say, you know, just because we didn't hear something on May the 5th, 1994 doesn't mean that there isn't intelligent life in that direction. We just need to go back and really try to understand the signals coming from various parts in outer space.
We've been listening for 56 years now, and no signs of life have been recorded. But if aliens are as noisy as we are, it could make things a lot easier for us.
The Earth is a very powerful radio emitter, because television signals are sent beyond Earth's atmosphere. So if I were an observer somewhere in the galaxy and I had a radio telescope, I'd be able to see that Earth is a strange, totally abnormal radio emitter.
Stay tuned for an NBC News special on Vietnam.
For over a century now, all of our radio and television programs are broadcasted using airwaves, traveling all around the globe and into space.
Because we're broadcasting all day, every day, anyhow. Television, of course, some of our radio goes out into space. The thing that actually is the strongest signal from Earth are the radars. So we're already broadcasting our presence.
Did aliens also invent radio and television? Are they just as evolved as we are technologically? An American team of scientists determined to find them has based its research on this premise. In California, south of the San Francisco Bay, American scientist Shelley Wright has developed a new instrument to record extraterrestrial messages of a more advanced technology. Operating on the Lick Observatory telescope on Mount Hamilton, this innovation is a world premiere.
So we're here to do a near-infrared SETI, so for the search for extraterrestrial intelligence. We're using detectors here to look for near-infrared light pulses that an alien civilization would be using to communicate across large distances across space between stars. So the idea here is that alien civilizations would be using really powerful lasers. So today, our laser technology in Earth is so good that we can outshine our sun by a factor of 3,000 across all of the optical and near-infrared band. You could put the entire internet in a laser transmission and send that signal across interstellar distances. So if that's true, if right now we could take our technology and communicate 1,000 light years away and basically shove whatever message we want into that, why couldn't we turn it around and ask whether extraterrestrial intelligence or other alien civilizations would be doing the same?
During their observation sessions several weeks a month, Professor Wright's assistant, with the help of two students, crisscrossed the universe, pointing the telescope at stars which are closest to Earth, hoping to receive an infrared signal sent from an exoplanet.
What is the magnitude of the star?
It's really dim, it's 9.86.
It was a main sequence star, located at something like 30 light years away.
No, it was much closer. Oh.
Was it?
Oh, it was like 10 parsecs.
Yeah, so 10 parsec would be like 30 light years away. We chose this star because it's very close, so the chance to detect a laser will be higher because the extension in the near-infrared is very low.
For now, no infrared laser signal has been recorded coming from space.
I think if we ever got a signal, the fun just began. Because then we'd have to figure out what signal was there, what was packed into that signal, what were they transmitting, were they sending their favorite novel, were they sending their favorite recipe? We don't know. I think that would just be the beginning of trying to unravel how we do communication and how we even communicate between different alien species. That's very complicated.
Would it be from a long time or would it be immediate because of the space and time?
It would take 1,000 years for us to send a message. So this is a very long timescale pen pal to be communicating across interstellar distances. But presumably, we hope humans will be here a long time. And we hope that other intelligent life out there would be there a long time as well.
What will we do if Professor Wright or another one of the numerous ears of the Earth ever receives a message? Will we even be able to decipher this message?
Well, I don't know. I mean, that's like asking, could Champollion have understood the hieroglyphics back in the 1830s? And he was able to figure it out.
The UN and some governments have put protocols in place to deal with extraterrestrial contact. It seems far-fetched, but it's better to be prepared, I suppose.
But what do you do once you pick up a signal? I think it depends on whether the aliens want us to understand it. If it's a message that's actually not just for us, I mean, it was just something we picked up, I doubt that we'll ever understand it. But if we did get a message, I mean, you know, in the future, I would advocate that we just put that on the internet and let everybody try. Let them all try.
What if this intelligent life form came to meet with humans who were the furthest away from their planet, the astronauts orbiting in the space station? It would be funny if it happened to me. No, I think we would have seen them coming. That's not something that just pops from outer space. Or if it did, it would probably be a bad sign. It would mean they've tried to hide the fact that they're coming. We don't think about that, that's fiction. It would be such a surprise if something were to happen that we would have to pause in shock and awe before trying to respond.
Despite what some might think, we're not actually prepared for an encounter of the third kind. But it is important to talk about it, to consider the possibility of such an event. The question of the alien needs to be part of our everyday life.
Earthlings have always imagined the first contact with the alien species to be disastrous for mankind.
The whole world is under attack.
Are they coming to wipe us off the surface of the Earth, or simply turn us into slaves?
When two living beings meet, there is always a risk. We know it can benefit or destroy one and/or the other party. If history is any guide, we have to remember how the New World was discovered at the expense of its inhabitants.
There have been debates about civilizations. Stephen Hawking has said some interesting things on the subject. For him, we need to stop emitting, because if a civilization that's more advanced than ours takes an interest in us, it will surely destroy us. History has shown that when two groups meet, if one is stronger, it will destroy the other. So we risk being wiped out.
Donc le risque, c'est d'être détruit.
I'm not sure to be just as moved if I only find bacteria. Of course, I'll be moved because it will mean we're not alone, which is the main thing. We don't need to find an alter ego. We always picture aliens to be a bit different, but a bit like us too. They mostly have 2 arms, sometimes 3, 2 legs, maybe 4, but on the whole, they're alike, when in reality, they might be something totally different.
On the other hand, I'm not sure that they would be living things at all, actually, because, you know, when you invent radio, you're only 100 years from inventing computers. And when you invent computers, you're probably only 100 years from inventing artificial intelligence. So I think on the basis of these arguments, the majority of the aliens out there, the thinking things, are not biological. They're not living things. They're synthetic built things. So if you meet the aliens, you might be a little dismayed. It's a machine.
If life is everywhere in the universe, why haven't we received any signal, any message?
That's the Fermi paradox. Where are they? It's a real paradox. SETI hasn't discovered anything. Flying saucers have been seen on Earth, but I don't take those too seriously. My opinion is if aliens had made the trip all the way over to Earth because we're a radio emitter or because our temperature makes our Earth livable for them, they've come all the way over here. Just think about it. Would they not try to say hello? They'd hide? That just doesn't make any sense.
I'm having a hard time, and I know others do too, imagining we're alone, especially since the universe is almost infinite compared to us. At least its size defies our imagination. What are the actual odds of us being the only living beings? It is very unlikely. The reverse argument is, if the universe is infinite, not only is there life, but civilization, and many other civilizations must exist. It's infinite. Among this infinite number of civilizations, one of them must have had the technology to contact us. And we could also argue, ad absurdum, that if we haven't been contacted, it means there are no civilizations out there. All I can say is, today we don't have the technology. We discover new exoplanets every day, now that we know how to look for them. And there's a possibility that we find one with people on it. There's another theory for this silence. Maybe many other civilizations have already existed, but none of them survived long enough to emit signs of life.
It could be that, you know, you have life on some planet and it becomes intelligent eventually, right? It'd be just evolution, you know, you get intelligent species and they invent radio and go on the air so we can find them. And then at the same time they invent radio, they invent bombs, right, big bombs. And then they go off the air. I mean, maybe that happens a lot. It could, maybe it'll happen to us, right? But on the other hand, the lack of signals, you know, if you say there's nobody out there, what you're saying is that every society fails. Every society fails. And, you know, that seems unlikely to me. It's hard to believe that 100% of all intelligent species self-destruct right away. You know, I'm not that pessimistic, frankly.
So all we have to do is wait, search, be curious, look at the sky and send space probes, because the question remains.
The discovery of extraterrestrial life, be it bacteriological or intelligent, will no doubt be the most important event for humanity since the apparition of life on Earth itself. But it will also be the case if we can prove we're alone in the cosmos. Both theories would be equally astounding for mankind. But in this infinite space-time, will humanity survive long enough on its planet to meet with other civilizations living on the other side of the universe?